Okay, so welcome to a short video on how to name organic compounds for level 3. So far up for organic chemistry, I just posted the level 2 and the level 3 organic flowcharts, which give you a great overview of how all the families are linked together and the various types of reactions and reagents that are needed in any particular experiments which are of particular importance. The next logical step I tend to take when teaching organic chemistry is to then revert back to showing students how to name organic compounds. And the rules are quite extensive for this. So what I did was I've just posted a scant page from a good chemistry book produced by Abbott and Eames called Organic Chemistry. Or this is from the chapter called Organic Chemistry. So I'm just going to read through this content just to refresh your mind as to what the rules are for naming organic compounds. And the rules are much the same as they were for level 2, the only difference being that we got some new organic families and therefore some new suffixes to consider. So because there are millions of organic compounds known, scientists have developed a systematic way of naming them called the IUPAC system, which stands for the International Union of Pure and Applied Chemistry System. The good thing about this system is that if you guys learn how to do this properly, then you could name organic compounds anywhere in the world and other chemists will recognize the naming system that you're using. So although some compounds are often referred to by their trivial name, for example, CH3COOH is commonly called acetic acid, although its systematic name is ethanoic acid. So each compound is named according to the number of carbon atoms it has in the longest continuous chain and the position of any functional groups or side chains. Prefixes, which is what comes at the start, and suffixes, which is what comes at the end, are used to identify the functional groups present. The naming of the longest continuous carbon chain is based on the names of the alkanes, and this name is indicated by the prefix to the alkane. So the first simple set of rules that you learn is that if you've one carbon, the alkane name is methane, the prefix is meth, M-E-T-H, and if you have a one carbon side chain, then it's referred to as methyl or methyl. And then it goes all the way up to 10, 10 being decane and the prefix being dec. You can see here with the side chains, the longest side chain you're going to come across is butyl, a 4 carbon side chain. So you can see the limitations of what you're expected to learn. A system of numbering is used to identify where a functional group or side chain is attached to the carbon skeleton. For example, consider butan 2-ol. So the an indicates that the compound is based on an alkane. The but indicates that there are 4 carbon atoms in the longest continuous chain, 1, 2, 3, 4. The ol indicates that an alcohol or OH group is present, right there. The 2 indicates that the OH group is attached to the second carbon of the chain, right there. And the chain is numbered from the end, in this case from the right, 1, 2, 3, 4, that is closest to the functional group. So you must use the lowest numbers possible when numbering side groups or functional groups. Suffixes are used to indicate the class of organic compound. Now when you're studying level 2, the organic compounds that you need to know are alkanes, alkenes, alkynes, alcohols, carboxylic acids. You need to also know amines and haloalkanes. And then, just I've handwritten here in pen in black, you also need to know for level 3 the acyl chlorides, the ketones, the aldehydes, esters, which used to be on the level 2 course, which has been shifted to the level 3, and amides. So the suffix for an alkane would be ane, for an alkene would be ene, alkyne, ine, anol is for an alcohol, anoic acid is a carboxylic acid, anoyl chloride is for an acyl chloride, anone is for a ketone, anal is for an aldehyde, anoate is for an ester, amide is for an amide. Amines you use the prefix amino, or you can use the suffix amine, and haloalkanes you use the prefix chloro or bromo. An example of each then is given in the right-hand column, far right-hand column, if you want to read through those. So the next step then is to go through some specific level 3 examples. Okay, so for my specific level 3 examples, I'm just going to go through a few different families that are prevalent on the level 3 flowchart. So you would have seen on the level 3 flowchart that alkenes aren't really talked about much anymore, and alkanes aren't really referred to much anymore. So if we start off with haloalkanes, I'll just write down an example or draw down an example. Now this compound is written CH3CH2 CH3, and there's a chlorine stuck on here. So the rules say that you must identify the longest carbon chain is the first thing. So the longest carbon chain, I like to use this, draw these little snakes, I call them, and around the longest carbon chain, which is pretty straightforward to see. The longest carbon chain has 4 carbons in it. There's a side group on here which is going to be referred to as chloro. The 4 carbons makes it a but prefix. So now we just need to number it, and we're going to number it using the lowest numbering system, 1, 2, 3, 4. Okay, so the name for this haloalkane is pretty straightforward. It's 2. You put a hyphen between numbers and letters. 2-chlorobutane. Now, I haven't seen any rule to state otherwise for IUPAC whether you join those 2 words together or leave a space, so it's your choice. You can write it as 2-chloro with a space, butane, or stick the prefix and the suffix together. But either way, the name for that compound following the IUPAC system is 2-chlorobutane. If we do another example, I don't need to go through lots of them for the haloalkanes because you would have covered them in level 2 as well. If we do this example, CH3, CH, 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 CH3, and then we have a methyl group here, we have a bromo group here and another bromo group there. So the first thing again is to identify the longest carbon chain. So we get my orange out again. The longest carbon chain here is this one. Just to show you, you could have also identified this as the longest carbon chain, because in either case you have 1, 2, 3, 4, 5 carbons, but it would have the exact same name. So I'm sticking with orange, and I'm going to number that with the lowest numbers possible. Now, to decide which is the lowest side group to give the numbers to, or which side group should get the lowest number rather, we need to consider which side groups are actually responsible for naming this family. So the bromos make this a haloalkane, so therefore they should get priority in terms of numbering. So we're going to number it this way, 1, 2, 3, 4, 5, as opposed to the other way around. In which case we have 2, 3, so 2, 3, dibromo. You have to indicate that there's 2 bromines, dibromo. So 2, 3 dibromo hyphen because we're going to a number again, number 4, methyl, and it's pentane. So 2, 3 dibromo 4 methyl pentane. So that's another example of a haloalkane. They don't get much more complicated than that. Okay, we're going to look at alcohols now. Alcohols are still a major focus on level 3, just as they were in level 2. Alcohols are that intermediate group which allow us to get on to carboxylic acids, and then opens up a whole other plethora of organic compounds you can study in level 3. So what we're going to do here is we're going to do the 3 types of alcohol, primary, secondary, and tertiary, and we're just going to practice naming them. So we start off with this one, CH3, CH2, CH2OH. Okay, the longest carbon chain is 3 carbons. So, and it's an alcohol. So what we're going to do is we're going to call it propan-1-ol. Now some people will call this propanol, which is acceptable, but I would advise that you get into the habit of indicating the position of the OH group, even for a primary alcohol, because once you have the habit, it's easier to follow that habit. You must indicate the position of the OH group for proper IUPAC naming. This here is a primary alcohol. It will be easier to see if we draw the structural formula where we actually open out the bonds from the condensed situation. So when we do that, and we need to identify what these elements are here, I like to call this the central carbon, central carbon, and joined onto the central carbon you just have one other, so that makes this a primary alcohol. Okay, so if I do another example over here, go back to my green, we have another example, could be CH3, CH2, C, CH3, CH3OH. All right. In this compound, the longest carbon chain is 4. So we can put bute down as the alkane name. There is a side group, 2 side groups. There's the OH group here, and there's the methyl group. So this is methyl, and this is going to make it the alcohol. So because this makes it the family, this contributes to the family name, this gets the lowest number. Again, the methyl gets less priority here, so the OH group gets the lowest number, in which case it doesn't matter because both of them are going to get the same number. So this is going to be 1, use a different color. Carbon 1, 2, 3, and 4. So in which case this compound is going to be called 2-methyl butan 2-ol. So we're indicating the position of the OH group here, and if you remove that number as well, just take note that you would spell butanol anyways. So you're still making grammatical sense, I suppose, if that applies here in naming organic compounds. Just to point out as well then what type of alcohol this is. So if we locate our central carbon, which is this one in this case, this one has 1, 2, 3 carbons stuck onto it, so this is a tertiary alcohol. A tertiary alcohol. Tertiary. Okay, so we could go through other examples, but that's the general idea for naming alcohols. If we move on to just take a brief note here, a diol is an alcohol which has 2 OH groups stuck onto it. So that could be an example of a diol there, and that would be positions 1, 2, 3. So that would be 1, 3. Sorry, just to fix that, it wouldn't be 1, 3. So if it's a diol, it would be, in this case, propan. So it's 3 carbons, so propan indicate the position of both OH groups, so 1, 3 diol. So propan 1, 3 diol, that's how you would name that one. So sometimes you get diols just thrown in there to test you guys out. If we take a look at a family which is new to level 3 this year and you wouldn't have seen them before, we look at the aldehydes. Aldehydes. And the aldehyde function group, which is C double bonded to an O, and then you have a hydrogen on the carbon molecule. So that's the aldehyde functional group. So if you see that functional group in a compound, you should be naming an aldehyde. So we start off with a simple one, just to introduce them. CH3C, just delete that. Again, CH3, C double bond O, bonded to H. Okay, so you identify your aldehyde group, and it's 2 carbon aldehyde, so what it is ethanal. And that's your suffix from we had at the beginning of the rules. That's your suffix for aldehydes. If we do a more complicated example, if we do CH3, CH2, CH, CH, carbonyl group at the end. The carbonyl group is always at the end, so you don't need to indicate any position, so that's easy with aldehydes. They're quite easy to name. You have a methyl group on here, and you have a methyl group stuck on here. Now here's a point to make when you're dealing with compounds which have a carbonyl carbon. Students often ignore this carbon when they're numbering, and if anything, this carbon is the most important because this is the functional group which gives it the family name, therefore it should get the lowest number and priority when numbering. So that's carbon number 1, 2, 3, 4, and 5. So the name of this compound is a 5-carbon aldehyde with 2 methyl groups stuck on it. So it's going to be 2, 3 dimethyl pentanal. Pentanal. And again, the anal suffix for the fact that it's an aldehyde. I'm just going to get a new page now so that we can work on to some other examples. We're going to take a look at ketones next. Okay, so with ketones, I'm sure you can see that they're very close in structure to aldehydes, and that's because they come from the same progenitor, which is going to be an alcohol. Now, aldehydes come from primary alcohols, and they're an intermediary step before you form carboxylic acids by oxidation, whereas ketones come from secondary alcohols. So they come from secondary alcohol parent, but they're similar to aldehydes because they also have the carbonyl carbon in it, so the C double bond O. The only difference is that the functional group is going to be a carbonyl carbon, and then you're going to have some sort of carbon side chain there, whether it be methyl, ethyl, etc., and the rest of the molecule. So that's the functional group for a ketone. And we'll talk a little bit about identifying the difference between aldehydes and ketones. It's a classic exam question. It basically involves the use of Tollens reagent or a Fehling's reagent to get some sort of color change. So with a ketone, if we do this simple example here, CH3, then you have your carbonyl carbon, and then CH3 again. The longest carbon chain is 3. You have your ketone group right there. But because the ketone group can now be sandwiched between two carbons, we have to indicate the position of the carbonyl group in a ketone. So that's something to take note. You must indicate the position of the carbonyl carbon, i.e. where this is located for ketones. Okay, so in this case, because it's in position 2, again, use your lowest numbering system, but there is only one option here, so position 2, this is going to be propan 2 on. And if you remove the 2 there, you would see that you'd spell out propanone, which is a 3-carbon ketone. If we do another example, let's do this one, CH3, CH, carbonyl carbon there, CH3, and then coming off the side of this we have our methyl side chain. Then this one is going to be, longest carbon chain is 4, your ketone group is down there in position 2 again, so use the lowest numbering system for your ketone, because that gives it the family name, and then it's going to be 3-methyl. So the name for this is 3-methyl butan 2-on, and that's how you name ketones. And next thing we're going to look at, okay, so next family to take a look at, which is also new to level 3, will be the acyl chlorides. So this is family number 5, acyl chlorides. Acyl chlorides, very reactive. They have the functional group. They have the carbonyl carbon again, so they are related to in some way to the ketones and the aldehydes. But instead of having a carbon or a hydrogen, they have a chlorine, and hence the chloride in the name. So that's an acyl chloride functional group. The rest of the molecule would be there. With acyl chlorides, the suffix is going to be anoyl chloride. So you're going to have that stuck on the end of all of the names that you name. They're quite straightforward to name because the acyl chloride functional group has to be stuck at the end of the compound, just like with aldehydes. Then there's no need to indicate the position of the carbonyl compound. So let's just do an example. So if you take a look at CH3, CH, CH2, C double bond O, and then there's your functional group right there. If we stick a methyl group on there, then the name for this compound, the longest carbon chain, remember, like I said before, don't forget to number the actual carbonyl carbon as number 1, because that's most important. So then this compound's name is going to be 3-methyl, and it's 4 carbons, so it's butanoyl chloride. So 3-methyl butanoyl chloride. So that's one example. And I'll do a second example here. I do CH3, CH, CH2, CH. There's your carbonyl carbon. That's your acyl chloride group right there. We've got to number it. We also have a side group, which is a 2-carbon side group, C2H5, which is going to be ethyl or ethyl. So this is going to be 1, 2, 3, 4, 5. So this will be 4-ethyl or ethyl pentanoyl chloride. And that's how you name that compound. Let's take a look at amines. Amines you guys would have covered last year, was introduced into the level 2 course last year. Let's get a different color. So amines will be group number 6 we're going to take a look at. Okay, the amine functional group is a carbon, so just use rest of the molecule bonded to an NH2 group. And amines are very like ammonia when they're in solution, so they behave as weak bases. They also react with weak acids to form a salt and water, and they would turn, if they're weak bases, they would turn red litmus blue. Just to make sure I get that right, so red litmus blue. For amines, you can, just like with alcohols and haloalkanes, you can have primary, secondary, and tertiary amines. Now, you're not expected to name them for level 2 or for level 3, but I'll just cover the system anyway in case you come upon it in future years outside of school. So we'll just take 3 examples and get this color. So if we do this one first, CH3, CH2, NH2. Okay, so this is what's regarded as a primary amine. And it's a primary amine because the NH2 group is bonded to just one carbon. So just like with an alcohol, central carbon is bonded to just one other carbon that makes it a primary alcohol. So the nitrogen here is akin to, it's like the central carbon in an alcohol when identifying primary or secondary alcohols. So that's primary amine. Now the name for that is aminoethane. Now other people might name that ethanamine, which is also acceptable, though the IUPAC system would be to name it aminoethane. Another example, a bit more complicated now. Take a look at this one, CH3, CH2, CH2, NH, CH3. Okay, this compound here now, if you see, the nitrogen is actually sandwiched between 2 carbons. So this is a secondary amine. Now to indicate that the nitrogen is actually sandwiched between 2 carbons, what we do is this, the nitrogen is essentially splitting this molecule up at this point here. So what we have is, it's a bit like naming esters, I suppose. There's a methyl group stuck onto the nitrogen right there. So we say nitrogen stuck to a methyl, so N-methyl, and then the rest of the molecule we then just tag on as the suffix, amino, and this is going to be propane. So that's what the N actually means there. It indicates the nitrogen is stuck to the methyl group, and then the amino is considered stuck onto the propane. So it's a secondary amine, 2 carbons stuck onto that nitrogen in the center. And to just show you what a tertiary amine would look like, just for an example, you could have, go back to my darker color here, you could have CH3, CH2, your nitrogen stuck right there, CH3, and then CH3. So because the nitrogen is now stuck onto 3 different carbons, this would be a tertiary amine, and this would be named N-dimethyl. So onto the nitrogen you have 2 methyl groups, and then the remainder is going to be aminoethane. So it's quite tricky when you get secondary and tertiary amines, but you don't get them in level 2, and I haven't seen any in level 3 either. But the same process applies to amides when you're naming them too. So I'll just go on to naming some amides. I'll do some esters as well, just because they're on to the level 3 course, and then I'll leave it at that. So I'll just get one more new page. Okay, so with amides, if we identify the functional group of amides, you mustn't mix them up with amines, which is the trap some students will fall for. You're going to have a carbon, which is double bonded to an oxygen, and then you have your NH2 group, and then the rest of the molecule. So the way I remember it is that there's a D in amides, and that corresponds to the double bond. Alright, so you shouldn't mix that up if you link the D in amides to the double bond. Okay, so naming amides, the suffix is going to be amide, so that's easy. So the suffix is amide. so something amide. And if we just look at some examples of a primary, secondary, and tertiary again, if I take this one first of all, CH3, C double bond O, NH2, that's your amide group right there. This is a 2-carbon amide, simple enough to name. It's ethanamide. Okay, so that's ethanamide. Now that's a primary amide. If we look at a secondary amide, and again, I don't want to be scaring you guys off, you don't typically get these in level 3. But if I give you an example anyway, CH3, carbonyl carbon is here, and onto the nitrogen you have a methyl group. So same system as with amines, because the nitrogen has something stuck on it, we need to indicate that. So we write down nitrogen, stuck onto methyl, so that's accounted for that, and then we just name it as normal, 2-carbon amide ethanamide. So N-methyl ethanamide. And I'll give you one example of a tertiary, so that was a secondary amide. One example of a tertiary amide would be the following. We just draw it down, CH3, CH2, C double bond O, or nitrogen is now here, and the nitrogen in this case has 3 carbons, and I'll just identify those for you. So it has 1, 2, and 3 carbons stuck onto it, so it's a tertiary amide. We just need to name this. And it's quite tricky because in this case, onto the nitrogen we have 2 separate side groups, and we need to use our alphabetical system. So this is ethyl, this is methyl. Okay, so what we have here is N-ethyl, because ethyl comes before methyl, N-ethyl, N-methyl, and then the rest of the compound, which is a 3-carbon amide, propanamide. So N-ethyl, N-methyl, propanamide. So that is the trickiest amide you'd come across. And you don't tend to get those in level 3, but that is how you name primary and secondary and tertiary amides. Now the last family to look at, which has been reintroduced into the level, well, has been swapped from the level 2 course to the level 3 course this year, is esters, or are esters. And students tend to have difficulty with esters because they're quite, the name is quite compound, so I'll just give you some examples and we'll go through that. Okay, so if I just do two quick examples of esters, there's one here. And the ester functional group is the carbonyl carbon again, because they originate from carboxylic acid, so that's why the carbonyl carbon is still present. You have a carbon single bonded to an oxygen, and then that oxygen acts as a linker to some sort of side group. And the side group here would have originated from an alcohol, so that would have been from the alcohol parent. And then this part here would have been from the carboxylic acid parent. And that's why esters look the way they do, because you took an alcohol parent and a carboxylic acid parent and you stuck them together. So you need to bear that in mind when naming esters. The other thing when naming esters is I want you guys to always identify where the ester group ends with a little line like that, because that there is going to be the suffix for the compound. So it's very important that you can identify the suffix for the compound, because then all the rest of the stuff is considered just a side group. So with that in mind now, hopefully you can name this ester quite easily. The suffix is always going to be OH and for all esters. So if we name this now, we have a side group which is ethyl, so ethyl, and then we have a 1-carbon ester which is going to be methanoate. So that's how you name that ester. So what we're saying here is that the parent alcohol would have been ethanol, and that the parent carboxylic acid would have been methanoic acid. We do another example. We take a look at this one here, CH3, CH2, carbonyl carbon, oxygen, single bonded, and then CH3. So again, get your pen out, identify where the ester group ends, which is right there. That means this is your side group, which is methyl side group, and you have a 1, 2, 3 carbon. Don't forget to number or to include that carbon in your counting. And that's something that students often forget. They forget to count that carbon right there. So this is a 3-carbon ester. So the name is methyl propanoate. Propanoate. And this is telling us that the parent alcohol would have been methanol, and the parent carboxylic acid would have been propanoic acid. Okay, so as far as I'm concerned, it's a good introduction to naming for level 3. You need to get out there and practice lots of naming. But once you can name your compounds, you can then start looking into the actual reactions and addition of reagents to get from one family to the other. And that's pretty much the focus for the remainder of the course. Just some samples for exam questions and lessons. I would have provided compilation of your level 3 past paper questions, so you should be trying to do those questions right there. I got some more here. So there are plenty of those available, and I've given those out in lessons. So any other questions, just post some comments, and I'll try to answer them.